What's up, guys? Welcome to another episode of CCT. So today I wanted to talk about just kind of the formula and how to do these binary tree problems. So there's kind of a recipe to doing them, but they could still be really tricky even knowing them. So I'll just go through the kind of the breakdown of how binary tree problems work, and then go through a few easier examples. All right. So the first part about the binary tree problem is, is the base case. Now, the base case in a binary tree problem almost always includes, like, if null returns something, it's almost always something like if null, blah, blah, blah. And that's because the binary tree problem basically ends once you get to like a leaf node, or not even a leaf node. You probably always you just want to go down to the null. Just let the algorithm go past the leaf node to the null pointer, and then you could end it there. So that's almost always going to be at the top as one, or the first base case in your binary tree. Because if the thing you're working with right now is, or the root, I'll say, that you're working with is null, then there's no point in continuing to these steps down here. Um, yep. But in addition to if it's null, another big part of binary tree or tree problems in general is the idea of pruning. So the idea that you get to a certain point and you know the answer already, whether that be true, false, like a number, etc. So I'll call this the you found what you're looking for. Looking for, aka pruning, meaning you don't need to continue down this branch to get what you need. All right, so that's the base case part of it. Now the next part of the binary tree is, I guess, the meat of the problem, which is the left and right. Do something on the left, or do something to both sides. Yeah, so there's a variety of things you could do with this. You could say like x equals foo on right, y equals foo on left. You could also it's possible that you could return things right now, so you could do just like return the max maybe of the two, if that's what you're looking for. Let's see, what else can you do? It is possible to actually only do one side, I guess. So you could have like some that keeps appearing here. You could have some if conditions to decide which side. Okay. But yeah, this is really the part where you have to use the idea of the binary tree. Like, oh, I can. Sorry. I see just double tap work. Yep. I could do something on the left side and the right side. Yeah, like whatever. Oh, yeah. So an example of like an if condition, decide which side to go to, that could be literally if it is a binary search tree, you could say, oh, if it's bigger than, if you're looking for a target and you have like something like this, and you're looking for the number 7, and this is your current route here, then you could say, oh, 7 is bigger than 5, so let's go down this path here. So that's what I mean by having a possible if condition. You don't always have to do stuff to both sides. You can often leverage the structure of the binary tree. Okay, third part is the, I should probably make it the same size. Yeah, what you return. Now this is a very tricky part, honestly, because what you return directly has to do with what step 2 is getting. And you also have to realize it should probably be in the same, whatever you're returning in the base case needs to be the same type that you're returning in the in like the final return statement. So some things that this could do is it could do some processing on this stuff. So like the stuff you stored from the left and right. It could, well, I guess in all forms, it's some kind of processing on the information you got from the left and right. But you also have to realize that what you're returning here is gonna get popped up on the stack for the like you see how x equals foo right? So this foo right is gonna return something here. So whatever you're returning here, you want it to be useful to the stack above. So whether that means like true or false or a number or something, yeah. So this is the formula, and I will say one of the trickiest parts is figuring out what to return and how that's going to be helpful to the stack above you. Okay. So what I wanted to do now is just go through some like quick, relatively easier binary tree examples, and then maybe in later videos I'll do some harder ones. Okay, so I have a list of some things we could go over. Okay, I like this one. So same tree. Actually, let me make that the same size. So it really always takes in a root, which is a point, or it has, it's not a point, it's an object that has a left and a right pointer. That's what all of them have. Okay, so the idea of, oh wait, we're not doing C++, just pseudocode Python-ish. If you don't know Python, it's fine. So the idea of same tree is that you, oh well, I guess you get 2 trees actually. Okay, the idea with same tree is to basically see if these are the, if you have 2 trees out here, like 5, 6, 7, you just want to make sure it's the same tree as here, like it's not, oh sorry, this isn't a binary tree. This question doesn't have to be a binary tree or binary search tree, it could just be a regular binary tree, whatever. And it's just making sure they're all the same. So I actually like to start these binary tree problems with step number 2, which is figuring, it's kind of like the meat of the problem, like what do you want to do with the left and right side? Okay, so we have same tree. So I think what I want to do is I want to, like, I guess I'm already thinking of what I want to return. I kind of want to return true if like these subtrees are the same. Yeah, I want to return true. Like this does return true or Boolean. Oh yeah, that's also like a clue. The thing that, I mean, you could have a helper function that kind of changes the return type, but the thing that usually you're going to return is already in the function. And then, like, that being said, I did say you could have a helper function to alter the thing that you're returning. But yeah, anyway, I do want to return a Boolean, so, and I want to ultimately return true. Like, if my root is here, there's three things I want to do. I want to make sure the roots are the same, and then the left subtree and the right subtree are the same. Okay, so what I'm going to do is have left equaling, oh, that's too close to there. So left gets same tree, and we're going to move both of these to the left. Yeah. Yeah, I don't need that. Yeah, so we're going to do that, and then the same for right. It's making sure both the right trees are the same, and then return. We could just make sure they're both the same. So return left. And right. Now, I kind of purposefully left off the condition that like check to make sure the roots are the same, because what I want to do is I want to incorporate the roots being the same as part of the base case conditions, specifically the pruning one. Because we found if they're not the same, we found what we're looking for, which is that they are not the same tree. But actually, but before we do that case, like I said, we should probably do the if null case. So if, now they both have to equal null, right? So if, and here's like the classic trick for if it's null, so you just do like not root 1 and not root 2, then return true, because we're good. They both got to a null point. Yeah, and then like if, so now we know they're both not null, so if either of them are null, so if, yeah, root 1 or root 2, return false. And now by the time it gets here, it's guaranteed that both sides, the left and the right for both, or no, the roots for both trees have something in them. Oh, yeah, and then I forgot. And then the pruning case is to make sure that, wait, could I, yes. That was stupid. Wait. Okay, one second. Let me highlight all of this. Yep, so the final prune case, if root dot val not equal root dot val, then we can return false here too. I don't know. Okay, yeah. I wasn't sure if I wanted to go through the whole problem, but I guess I will, just to show you the idea. So here we have the base cases, and this is kind of like part, what the heck? I did not go to eraser. This is like part A for making sure things aren't null before we start actually working with it. This is part B, kind of pruning, because we got what we wanted. We now know that that these trees aren't the same, so we could return false here. Part 2 is knowing what you want to do to the left and the right side. So in this case, we kind of wanted to make sure that the left and the right subtrees were the same, we just wanted to get their values. And 3 is kind of the idea of like processing that data that we collected from the left and the right side. Yeah, so should we do one more? Yeah, let's just do, let's see. Maximum depth. Okay, let's do the height of a tree, and then we'll be done with this video, and I'll also make more videos on binary tree stuff. So let's get height of the binary tree. This is like a very classic example. So you get the root. And so what do you want to do? Let's start with the meat of the problem again, which is part 2. What you want to do with the left and the right side. So let's see. You want to So this is going to return a number. Like, it's actually going to return an integer. So what do we want from the left side? If we do get the height, and by the way, height is the longest path. So if the right side only stops here, but like the left side keeps going, then the height is going to be 4 for this, in case you didn't know that. So what do we want to do on the left and the right side? Like, we could kind of take a recursive leap of faith. What would we want if we could get it? And so my first thought is, okay, it would be really nice to know the height of that subtree and the height of this subtree. That would be really useful information if we were to figure out the height of the tree starting at this root. Okay, so what I'm going to do is I'm going to get the left's height, which I'm literally just going to do this, and then the right's height, oh yeah, left, root right, okay, but then what do we want to do? What do we want to return if we knew this? And I know this is difficult thinking if you're not used to recursion. Like, well, how do you know that you can get this side? Like, you haven't even implemented anything in height yet. Well, it's kind of the idea that we build up from the base case, but now we're like assuming that we're in a regular case where our root's here, and we just have these two options. So which one? So what do we do? And what we do is we can get the max of the left and the right, because remember I said that the height is the maximum height, and then we could add 1. And ultimately, this 1 is the only thing that's actually adding. This is getting to more of a recursive topic, but yeah, like basically it's like +1 here, you get the +1 from here, you get the +1 from here, and by the time it gets to here, you're returning a value of 4. Okay? So yeah, this is what you can return, and then base cases, well, what do you think the base case is? So remember, we definitely have to do something if the root is null, because if the root is null, then, well, we can't do any of these. We're going to get like errors because you can't do root left. Oh, these should be dots. Dang it. I'm like in a weird place between C++ and Python, but this is like still pseudocode. But anyway, if it's null, we just have to return what? True? False? No, we return 0, because the if this is null here, the height of this is just 0. There's nothing there. Okay? So again, we have our base case here. This is kind of guarding to make, this is the first part where we make sure that it's not null. Then we have the meat of the problem, and we had to think about that, like what are we getting in return, and then we decided we wanted to store them, and then what we return. Okay, so I hope this gives you an idea. Let's zoom back into here about how to do these binary tree problems. I'm gonna do some more videos on them because actually binary tree problems are my favorite. It sometimes gets really cool with how you think of what you return in step 3 and what you're getting from step 2. So I'll leave this video at that, and yeah, I'll see you next time. Also, yeah, one more thing. Somebody recommended or asked for this video. I definitely do suggestions, and yep, leave a comment if you want me to do anything else. Alright, thanks for watching, guys. See ya.